So we're now going to look at inverse and reciprocal trig functions. So you may be familiar with inverse cos, inverse sine, and inverse tan. You use those to solve trigonometric equations quite often. We're now going to give them slightly new notation, which is arc cos being inverse cos, arc sine being inverse sine, and arc tan being inverse tan. So you will see this notation being used for inverses. And I just want to point your attention that this is not the reciprocal. As you can see, we're doing inverse and reciprocal. They are different things. So the -1 here is not a power, which I know is very confusing because it normally is, but when we're looking at these trig functions, it's not. So referring to the inverse, we may call them arc cos, arc sine, and arc tan. So we want to be able to sketch these functions because you could be asked to do that in an exam setting. So one thing that you may remember is only one-to-one functions have inverses, and we can see quite clearly that our trig graphs are not one-to-one functions. So to do that, and to be able to sketch them, we have to restrict the domain, which is what x can be. So I've sketched my graphs of sine, cos, and tan, and we basically need to restrict these so they are one-to-one functions. So we're going to do it as close to 0 as possible. So we're going to look at where we are as close to 0, where we are a one-to-one function. So for sine, hopefully we can see it's here between negative pi over 2 and pi over 2. That is where we are a one-to-one function. So that is what our domain is going to be. So we restrict the domain, so x is between pi over 2 and minus pi over 2 for sine x. Then for cos, we can't go either side of the axis because we can see that it's clearly not one-to-one. We have multiple values of y, so multiple values for x for a value of y. So we're going to be on this side of our graph here, and hopefully we can see between 0 and pi. If we restrict our domain there, we have a one-to-one function. So for cos x, we are restricting the domain between pi and 0. And then for tan, it's the same as sine. We can see here on either side of the graph here, and our asymptotes quite nicely show us where we're going to restrict our domain. So it's the same as sine. We are going to restrict it between minus pi over 2 and pi over 2. So what I've done here is I've just sketched y is equal to sine x within our restricted domain between minus pi over 2 and 2, where it's a one-to-one function. So I'm hoping we recognise with inverses, when you've done inverses before even at GCSE, the y and x values basically just swap round. So where x is pi over 2, y will become pi over 2 for its inverse. So that's why I've got pi over 2 and minus pi over 2 on both sets of axes, because that will help us to sketch it. Another thing we might recall is it's going to be a reflection in the line y is equal to x. So I'm actually just going to draw it on the same graph first, so hopefully we can see that line of symmetry. So when x was minus pi over 2, y was minus 1, so let's switch that round. So when x is now minus 1, y is now minus pi over 2. So that coordinate is just going to go here. Then 0, 0 is going to remain the same. And then when x was pi over 2, y was 1. So now when x is 1, y is now pi over 2 up here. And then we want to make it look like a mirror image of y is equal to sine x in the line y is equal to x. So that's going to look something like this. So the tail is going to come here, it's going to meet 0, 0, and then it's going to go away again like that. We sketch it on a separate axes, so we know it's going to be minus 1 minus pi over 2, 0, and 1 pi over 2. Okay, now let's have a look at drawing arc cos x. So drawn, it's within our domain restricted between 0 and pi. Again, I've put all the values on all the axes because we're going to swap the y and x axes. We're going to swap the y and x values for cos and arc cos. So it's again going to be reflection y equals x. Now, I find it a bit harder to see it for cos, but when I plot the values, it helps you sort of know which direction the line's going to go when you think about its mirror image. So let's consider here. So when x is 0, y is 1. So therefore now, when x is 1, y is 0. So we're going to have 1 point there. Another key point, when x is pi over 2, y is 0. So now when y is pi over 2, x is going to be 0. And then we have here, when x is pi, y is minus 1. So now, when x is minus 1, y is going to be pi. So that's going to be up here, like so. So we can see our points, and hopefully using the mirror image of in the line y equals x, we can see what that's going to look like. So it's going to go up here, and then around like so. And that is what arc cos x is going to look like. Sketch that on our other graph. So we're going to be at 1, 0. We are going to be at 0 pi over 2. And we're going to be at minus 1 pi up here. And it looks like this. So that is arc cos. Let's have a look at tan x. So this is what tan x looks like with the domain restricted between minus pi over 2 and pi over 2. So now let's consider what arc tan would look like. So for arc tan, remember, well, for tan, we have our asymptotes. When x is pi over 2, we have an asymptote. So that means when, for the inverse, or arc tan, when y is pi over 2, we're going to have an asymptote there. And similarly, at x is minus pi over 2, we have an asymptote. So when y is minus pi over 2, we are going to have an asymptote there now instead. Now let's have a look at actually sketching arc tan. Now we know where our asymptotes are, and we know it's going to reflect in the line here, y is equal to x. So I think it's going to start here, and I think it's easier to sort of go backwards. So it's going to go through here, and then it's going to go down to this asymptote down here, like so. That might be a bit hard to see, so let's just highlight that. So let's just sketch that on its own graph now. You can do this on your calculator, but I just wanted to know where those graphs come from. So if you go onto the calculator and you press 5 for graph. So what I'm going to do here is I'm just going to do, so sine x, comma, then I'm going to do the square bracket, and I'm going to do the square bracket by pressing shift, and then down here, the plus and minus have the brackets on. So I'm going to do bracket, and then I'm going to put my domain. So pi minus pi over 2, and then another comma, and then pi over 2. Then close that bracket. And then what I'm going to do is I'm then going to, in y2, I'm going to do sine inverse x. And then I'm going to draw that, and hopefully we can see there, we've sketched both of them. And if you want to, if you just want to see arc sine, what we can do here is just deselect sine x and draw it, and then we can see that's what arc sine x looks like, and that is what we sketched before. And you can do the same thing for cos and tan. So we can see there tan x and arc tan x, and we can see there we've got our two graphs. And Let's now have a look at this question. So we have here, this sketch shows a graph of y is equal to inverse sine x, which is the same thing as y is equal to arc sine x. So we want to write down the coordinates of P and Q, and then sketch this thing here, which would be a transformation of arc sine x. So first of all, P and Q. So if we think about what sine looks like, we know that x and y values just swap over. So this value will be 1, this value will be minus 1, this will be pi over 2, and this will be minus pi over 2. So Q is 1 pi over 2. Make sure you get the x and y coordinates the right way around because we're flipping a lot of things. And P is minus, see I'm doing it now, it's not minus pi over 2, it's minus 1 minus pi over 2. So that's probably the slightly easier bit, that's just labeling the coordinates. Now we've got to sketch this thing here. So the actual what graph transformations do doesn't change, it's just the graph that we're transforming looks a bit different. So this minus bit here, we know that's going to basically make all the y values negative, it's going to switch the sign, so it's going to minus the y's, so flip them, and then this is a translation. Remember, if it's something to do with x, be the opposite, so it's going to add 1 to all our x values. So let's have a go at sketching that. So the y values are all going to flip, so where we had minus pi over 2, so what I might do is I might actually just sketch minus arc sine x first, just to see, and then do it in 2 stages. So we had pi over 2, that's now going to be at minus pi over 2, 0, 0 is still going to be the same, and then minus, we had our coordinate here at minus pi over 2, it's now going to be at pi over 2, like this. It should be a reflection in the x-axis, if you remember. So that is just minus arc sine x. So we've not fully done it yet. We've just sketched minus arc sine x in this case. We're now doing a translation of plus 1 in x. So where it was 1, it's now going to be 2. Where it was 0, it's now going to be 1. Where it's minus 1, it's now going to be 1. So all these values are just going to shift along 1. So this value here is now going to be here. This value here is now going to be here. And this value down here is now going to be down here. So let's just sketch that out. Like so. And that is going to be our fully transformed graph. And that is going to be y is equal to minus arc sine x minus 1. So sketching minus 2 arc sine, and then it's minus x in the brackets. So let's think about what those transformations mean. So this minus sign here means that all our y values are going to just, their signs are going to flip. If they were positive, they'll be negative and vice versa. So the 2 will be a stretch of scale factor 2 in y. So that means all our y coordinates will double. And then the minus x here, that is going to be again changing the signs of our values. This time it will change the x value. So all our x values, the sign's going to flip and it's going to be a reflection in the y-axis. So let's first of all, let's just sketch sine x first. So let's just sketch sine x. So here I'm going to do this minus 2 bit first. So the next graph I'm actually going to sketch is minus 2 arc sine x. Now you could do this, you could do the 2 bit and then the minus separately, but I'm going to try and do it in one go. I feel like I can. The y coordinates flip, so it's a reflection in the x-axis. So the pi over 2 here, so when x is 1, y pi over 2, the x coordinate's not going to change, but the y coordinate's going to flip. So that coordinate that was here, flip it in the x-axis, it's going to be here. But then it's minus 2, so double that, the pi over 2 would be down here at pi. 0, 0 is nice and easy. It doesn't change. It doesn't matter if we flip it. It doesn't matter if we times it by 2. It's still 0, 0. And then this minus pi over 2, flip the y coordinate. So it's now positive y over 2. x coordinate's still the same, -1, and then double it to pi. So that coordinate's now going to be here. So let's now sketch that. Finally, let's do the final transformation. So -2 arc sine minus x. So let's look at this graph and then think it's now going to be a reflection of the y-axis because all the x coordinates are going to flip and change sign. So we were at -1 here. We're now going to be at +1. So that coordinate that was here is now going to be here at +1, 0, 0. It's great. It doesn't change. And then here, this coordinate here where it was x of 1 is now going to be x of -1. So it's just going to flip and go here. And then let's just draw that. Right, let's have a look this time at y is equal to pi minus arctan x. I'm actually just going to rewrite that as y is equal to minus arctan x plus pi. I'm going to rewrite it like that because my brain just works better like that. I can see the transformations a bit easier. So this minus here, so again, the y coordinates are all going to flip and it's going to be a reflection in the x-axis. And then this plus pi bit, a translation in y of plus pi. So we're going to add pi to all of our y coordinates. That's all we're going to do there. So again, I just sketch out what arctan looks like first. Let's consider, I'm going to do the minus bit. So I'm going to do y is equal to minus arctan x. Let's have a look at that one now. So this is going to be flipping all the y coordinates. So if they were negative, then are positive, vice versa. It's going to be a reflection in the x-axis. So our asymptotes won't change. They will stay exactly where they are. It's just now where it was at pi over 2, it's now going to be at minus pi over 2. So we're going to have that point sort of starting down here, 0, 0. It don't change. And then here when we're at minus pi over 2, sort of here, we're now up here towards pi over 2. Now it's not actually touching because remember it's an asymptote, that's sort of their thing. So then let's just draw that. So that's minus arctan x. And then finally, let's finish it off and do the plus pi. So minus arctan x plus pi. So you can see my axes here. I've actually not got a negative axis because what happens here, if I add pi to all my y coordinates, so we're shifting up here, that minus pi over 2 is now going to be at pi over 2. So let's now draw that asymptote there. And then where it was at pi over 2, we're now going to be at 3 pi over 2. And you can see from my other graphs, the asymptotes are sort of lining up, but the asymptote would be about there. And then where I was at 0, this now is going to change. It's going to move up. It was at 0, add pi to it, it's now here. So let's sketch that. So we're using this shape, but we're just shifting it up. But that will be minus arctan x plus pi, or what we originally started with, which was pi minus arctan x. They will give you the same thing.